In this video, we demonstrate how to generate a decentralized JSON or DJSON for a GitHub Markdown article on OmniStar Web. This seemingly trivial example may represent one of the biggest breakthroughs in decentralized computing since the invention of Bitcoin itself, as it breaks the miners' monopoly of blockchains and cryptocurrency, and creates a practically zero-cost solution as alternative for the centralized domain name system and cloud computing services. Besides, OmniStar Web will provide the decentralized infrastructure and protocols for the red-hot artificial intelligence era, an issue that is still relatively underexposed. The first 4 steps shown here are just standard procedures to make a copy of the web page on a web server. The novel and crucial step here is step 2, where the document URL is converted to a 53-bit hash number, encoded in base 64 string. This hash code is then used to create a subdirectory to store relevant files, including decentralized JSONs. In the video clip, we use FOSScript metaprogramming language, which uses reverse polish notation syntax derived from the 4th programming language, run in the browser console as a command shell in JavaScript. The input string that is the document URL is pushed onto the stack as FOSScript employs a stack machine architecture. Next, edge 53 : corresponds to a function for 53-bit integer hash, B64 : converts the hash number to base 64 string, and path : converts characters for Linux filename compliance. The function t open close brackets shows the result stored at the top of the stack, which is E5BNWOBDVG ==. The video clip shows the hash root directory with a single letter edge. Each hash directory corresponds to one document URL. The subdirectory auth edge is the PHP backend module for OmniStar Web, and the subdirectory FOSS-PEdgeOS is the FOSScript frontend module. A local copy of the GitHub Markdown article is placed in this hash directory, together with several soft links. Index.php simply loads the HTML file and set up the function OmniStar to initiate OmniStar shell. We have now completed steps 1 to 4 for setting up the local copy of the GitHub Markdown article on OmniStar Web. Now let us look at step 5, that is to open OmniStar Web Server using I2P Invisible Internet Project website. The complete setup of I2P router on Firefox and Android are given in 2 other separate videos. We will skip these steps and open the hash address via a link given in GitHub page as shown in the video. We use the screen magnifier to zoom in on the address bar to look at the hash address in details. At the end of the address are GET parameters passed to the server, starting with a question mark. NN means nickname and its value is a single letter Z. The hash address starting with E5B precedes the GET parameters, which is in turn preceded by a single letter directory H. Preceding this is the long I2P address ending with B23.I2P. We are now at step 6, to initiate OmniStar shell by entering the command OmniStart in the browser console. Pressing function key F12 will bring up the browser console. Enter the command OmniStart open close brackets and press enter. A window with a yellow button labeled with the user's nickname together with a dialog box to enter commands will appear. OmniStar shell is the best solution to integrate graphical user interface and command line interface through browser console, where new functions such as light can be added to a web page and tested with minimal efforts. We are now at step 7, which is equivalent to login on conventional websites. This is the most crucial step which differentiates OmniStar Web from conventional websites, where we use RSA or public key cryptography for login and generate the hash of public key as user identifier. Click the button labeled with AUT edge for authentication. An alert window will pop out showing null result, indicating the authentication token needs to be refreshed or regenerated. To simplify programming efforts, the private key for authentication is kept in a different tab of the Firefox browser. Click the Authenticate button again and the alert window will continue to show null result. Clicking Gen Keys button will refresh the authentication token, where the server backend will send an encrypted secret phrase, which needs to be decrypted using the private key in the front end, and sent back to the server backend for authorization. Now clicking Authenticate button will bring up the alert window showing the secret phrase as P, login time and PB key or public key, which is a very long string. Now we may switch back to the hash address page of the GitHub Markdown article and execute the command as :x : by clicking the yellow nickname button label with Z. The alert window will display results from the server backend. The most important result here is the user identifier, shown here as CXAGCRKEVA ==, which is the hash of public key, as the public key is too long for most practical purposes, so it is shortened using a hash function. The hash of public key is actually the most important foundation of Bitcoin and other cryptocurrency and blockchain frameworks, as it is how Bitcoin address is derived. This principle is most unfortunately buried amongst too much noises, so few programmers would notice and understand its significance, and is now uncovered in Omni Web as user identifier, which will underpin all other decentralized transactions on Omni Web. We are now ready to perform the final step, to generate the like status, represented as a decentralized JSON, and send this DJSON to the backend. Notice we have not generated the like button, which is a trivial task that a junior programmer may perform. We will just execute the FOSScript commands from browser console to perform this task. As shown in the video, a FOSScript command is called via a JavaScript wrapper function f, and the FOSScript commands are enclosed as a long string, with words separated by space. It is perhaps the most compact form of programming language, and each word represents a function call to the host environment, which is JavaScript in the front end and PHP in the back end. So FOSScript basically unifies both front-end and back-end programming in one metaprogramming script, which in itself is a significant breakthrough in software engineering. Generating a decentralized JSON for like is equivalent to clicking the like icon on a social media post. In this case, the most important parameters are the hash of the current web page, which is stored in the JavaScript variable ht0, and the like parameter is highlighted in the video. Pressing enter will execute the FOSScript command and send the decentralized JSON to the backend, which will return the results through the alert window in the front end. We may examine the decentralized JSON on the backend server with Linux shell command ls -lt, which shows all JSON files in reverse time. The file names of the JSON records themselves are hash codes, which makes it convenient to be referred to in other operations or transactions. Finally, we display the latest decentralized JSON using the cat command, and the fields shown are timestamp, action type which is like, current user hash ID, hash of owner of previous message, hash of current web page, and remarks.